Grant. Hi, Michael Walsh, Senior M&E Engineer, Department of Education. I work in the Planning and Building Unit. I just want to say thanks for the invitation here and for the great hospitality. The lunch was really good. I hope you'll agree. In my presentation, I'll try to keep it short and sweet. As Carl mentioned about Pathfinder, we've been running Pathfinder for a number of years, and just like to take you through that, some of the projects that we've done, some of the challenges, and how the Pathfinder gives us learnings on how to scale this up to a much larger project to retrofit far more schools in the future. So, as I said, we've been running this for a number of years, since 2017. So it's multi-annual, and it's in partnership with SEAI. I'd like to thank Limerick Clare ETB, who've been very helpful as a partner as well. It's match funded in a partnership between Department of Education, DEC, and SEAI. So as I said, the key objective here is to learn, to get learnings on how buildings can be successfully energy retrofitted to become energy efficient, because we've got a massive challenge ahead of us over the next decade. So we need to learn how to move that forward. And so that, as I said, needs to be scaled up for the next 10 odd years. On the screen, you'll see some of the schools that we've worked on over the last few years. This is just a flavour of them. And as you can see, there are a variety of different building types there, which is what we want, to learn as much as possible for the portfolio that we have. So on some numbers, here's just a snapshot of the project over the last few years in terms of the number of schools retrofitted and the overall budget. And as you can see, we've changed the focus a little bit over the years. Deeper retrofit, lighter retrofit, more money, less money, just to learn as much as possible so that we can scale this up. I'd just like to talk a little bit more about this year's Pathfinder on the project brief for this year. Broadly, the target is a BER level B. And now most of the buildings that we've been retrofitting are falling in somewhere between a BER C, D, and maybe the odd E. So it's a good challenge to get to a B, really is, on an existing building. A lot of them would be 70s builds. They could be from the 40s or 50s with solid walls. So very, very kind of structures. A little bit more on the details. So the brief here is on the heating system is our focus really. And we want to provide 90% of annual space heating energy demand. So if you think about it, I think it was a little bit too earlier. This is where heat pumps really fit very well in. I think Jerry, you mentioned about it. Ireland has a very mild climate compared to the rest of Europe or the world, and heat pumps can work very well here because we don't have many days less than 4 or 5 degrees, and the number of days that are frosty days, etc. They're very cold, but they make up a very small percentage of the overall energy demand for the building. So there can be some technical advantages and some capital advantages to installing heat pumps, because you can install a smaller system, then you don't have to carry the whole heating load of the building. You're probably looking at somewhere between 60 and 75% of the total heat demand of the building would give you that 90% annual energy for the whole year. Very important though for heat pumps is because the temperature they operate, they generate heat at a much lower temperature, normally around 55 degrees Celsius as opposed to 75, 80 for a traditional boiler. They operate efficiently at that temperature. If you push them higher, they won't be efficient. But that comes with challenges, so you need to limit the fabric heat loss of the building. Really, you want to get down to around 55 watts per meter squared, and that's been our target, or where we want design teams to go to for the pathfinder. The other alternative is biomass. Now this isn't, the fabric here is not as key, but of course we want to address the energy efficiency as well. Because the biomass boiler can generate water heating at similar temperatures to a oil or gas system, it's a little bit more forgiving in that nature. John spoke a little bit about biomass earlier, and we are pursuing, from what we've learned in the past, an ESCO model, which is a energy supplier contract or energy supply company, I believe it is, and they manage the maintenance of the plant, help with the procurement, so it's better managed and easier for the end user. And we're looking as well for obviously the carbon savings, 50%, and we involve an EED expert, so an energy efficient design expert, to help and to work in partnership with the design team to ensure that energy efficiency expertise is brought all the way through the process. And they're also involved in the, after the practical completion, in the operational performance with checks of the building down the road to ensure that it's meeting what we had set out to achieve. So you can see those key numbers here. So the challenges that we've identified, I'll just run through 4 of the big ones here. If you're going down the road of heat pumps, and it's really topical at the moment, is adequate electrical infrastructure. With the winter that we're going to, even more so, heat pumps use a significant amount of electricity. So you need to very carefully think about what the electrical capacity of the building is, because they're using energy that would have been electrical energy rather than burning gas or oil. So you've got a smaller gas or oil bill, but a higher electrical bill. So it needs to be balanced out. So that needs to be very carefully checked, and it may need to be limited in terms of the overall capacity. As I mentioned before about the fabric improvement, is very key for heat pumps due to the lower temperature that they operate. So heat recovery ventilation was touched on earlier. In a classroom in particular with fairly high occupancy, 30 odd people, there's a high ventilation load. This makes up a huge heat loss if it's natural ventilation. So you're probably looking in the region of 1/3 overall heat loss. So if you can incorporate mechanical heat recovery into the classroom, you get a big reduction. It grabs about 80 to 90% of the heat that would have been otherwise wasted. So that usually helps. And again, in particular to the heat pumps, the heating distribution system, it needs to be considered. It can be compatible, but there are challenges. So we like to focus on the fabric approach first, and that's key for energy efficiency and good practice. So the menu that we're looking at here is cavity wall and external wall insulation. You can see there is the bones of the building wrap, as it's called often. Very cost-effective way is attic and roof insulation. Suspended timber floors sometimes. They're not always around, so you could do those when they exist. Windows and doors can be very helpful, but they do have a fairly large capital cost, so that needs to be managed as well. Air tightness improvement is a huge one. You can get a good saving on your energy efficiency from relatively minor works on that, and it's especially important if you're doing heat recovery ventilation. In the table there you can see some of the Q values that we're typically looking at for our retrofits. Then moving on to the M&E. So as I said, heat pumps or biomass. On the top right there you can see a heat pump enclosure or a heat pump compound as we call it. Usually it's air source heat pump is what you see there. It's basically an air conditioner working in reverse. and has worked quite well. As I said, heat recovery, ventilation, other things that come along with it. Because of these more complicated building services, controls are key. You need to operate these equipment as efficiently as possible, as was said earlier, that you don't want boilers running in the middle of the night, so it needs to be very carefully managed. And as I said, the heating distribution as well. Lighting upgrades can be a fairly easy win, but a lot of schools have done that already. Controls as required, of course, for the lighting. Simple things like hot water, time clocks. Now for schools, the hot water demand is quite low. It might differ in an ETB where you've got some specialised training. The hot water loads would be higher possibly. PV, as John said earlier, it's been very successful for us. It's reliable, almost fit and forget, although we don't live in the sunniest country in the world. Funnily enough, because it rains so much, it can keep those quite clean. And also the cool temperatures allow PVs to work more efficiently, but they're quite effective. So just to move on to an example, a school that we have retrofitted, really interesting school down in Limerick, Coláiste Yusuf in Kilmallock. Here, as you can see in the picture, it's modern and all sorts of designs there. I think it was 1920s originally, if I understand correctly. So on this one, and I'll go through another example as well, the next slide. You have to very carefully manage the aesthetics here and try to work with, obviously, the planners, the design team, and get as much improvements as you can with keeping the character of the building. So on this one, we've done wall insulation and windows in target areas. We installed new heat pumps, MVHR, mechanical ventilation heat recovery. As you can see there on the middle bottom picture, it's an arch room. There's a ventilation unit there. New heating distribution, hot water upgrade, and we did the air tightness on that as well. Another school which we took a different path here in Dublin, Drumcondra, Merrifield College, another interesting building with that red brick facade. Again, it's like Coláiste Yusuf, very careful and be sympathetic to the building. So any sort of retrofit needs to keep that in mind and keep the character of the building. So again, the insulation was targeted to the, I believe it was the 1970s and 1980s part of the building, which was inefficient and of limited architectural interest. So that was upgraded. And we improved where we could, keeping the character of the building. This one, on this building, we went down the route of a biomass boiler, which supplied again the 90% annual renewable heat. On this one, any instances where the biomass boiler couldn't cope, as I said, it provides the 90% of the heat. There is a gas boiler there to provide extra heat for those very cold days that rarely come. The BER on that one moved from a D1 to a B3, so a nice improvement. Again, because of the character of the building, it's somewhat limited what you can do on that, and we learned a lot from that. Then typical outcomes, just to start rounding out the presentation. 45% energy savings we found through the Pathfinder. 58% reduction in CO2 emissions, so really strong reductions there, so we're very happy with that. And that 90%, I suspect it possibly is a little bit higher, 90% of space heating demand met by renewable heat. And more important than anything, we are the Department of Education, so we have other things to care about as well, and the feedback from teachers and students has been very good. Due to the insulation, the ventilation, the improved heating, the comfort in the learning environment has been much improved, and feedback has shown that. And this final slide here, this is one of the schools of David Monaghan, St. Mary's National School, I believe. And it's quite a large national school, and you can see there on the top left, taken a very dreary day, of course, just to make it look worse. There's been a huge improvement to what we've got now with the external wall insulation, nice rendering, nice painting. Internally, I won't go on, but improved building services, and the feedback there has been really excellent. And you can see, like, if a student goes there or a parent, which it's a far more attractive building now to attend. So yeah, thanks for your attention. I'll hand you over.